Very good evening, everybody. Welcome back. How are we today? Another day, another opportunity to learn more and keep expanding, keep increasing our knowledge base. It is it is not only for you, but also for us. We also do some amount of preparation before we get into this phase here. So it is not just the half hour that we are, connected at the same time, but also at least the same amount of time beforehand we connect and we discuss what is to be covered or what is to be communicated to the participants through this dialogue, which is the interview session. So yeah, please do take adequate benefit out of it. Bharani is not available today. He may join. He's busy with an important call, so he may join at a later point of time. Otherwise, also, as they say, the show must go on. So the topic for today is naive Bayes, and we'll be discussing about the naive Bayes, the Bayesian classifier, and then within that, we'll also be discussing about the various hyperparameters. So there's only one person to be interviewed, Sharath. Everything comes to you. I have a very easy job of, only asking the questions and troubling you. So can you briefly tell me about what naive Bayes is and what is its purpose? What is its advantage in context or vis-a-vis other classification or other predictive models?
Good evening, everyone. Thank you so much, Nathan. Yeah, I get the opportunity to answer all the questions, right? So I look at that as a better side or an advantage for me. Good evening, everyone. Good evening, all the audience who have joined us, and yeah, welcome back to the channel. Today, we are going to discuss about the naive Bayes classification model, or naive Bayes model rather. It's a shallow technique. The question that I've received from Nathan is, what is naive Bayes algorithm and where specifically we use it? What are the basic different advantages or pros and cons with respect to naive Bayes algorithm? So when we talk about naive Bayes, let me just try and share my screen. All right, so this is our mind map. You might want to refer to the mind map. Whenever you're trying to learn things, it's always good to have this kind of overview. It will enable you to try and do the correlations, cross mapping of different topics. So here under data mining, we have supervised learning. And when we talk about supervised learning, it is all about predicting the outputs. So these are predictive models, right? So we need to try and predict the output. And labeled data will be there, and we try to define the pattern. But the scenario is we may not always try and find a mathematical equation which can express the relation between y and x in an effective way. For example, what if output variable is non-numeric? Isn't it? So I cannot simply come up with a mathematical expression. Arithmetic operations, basically, that's what I mean. So in these kind of scenarios, we need some alternative approaches which can actually allow us to try and estimate a non-numeric output given factors that are influencing those conditions. So in these cases, we have shallow machine learning models that we can use. And these shallow machine learning models, right, are primarily categorized into three different approaches. The first approach is that we are discussing today is naive Bayes. And it's a very popular algorithm. You probably have learned it in your primary education itself before your 10th grade. You probably will be familiar with naive Bayes probability concepts. In simple cases, we are trying to understand conditions-based probability, or you can say conditional probability. So what we are basically saying is, I need an output to be calculated, but there's a condition. The condition is that the values of your input factors are these: x1, x2, x3, x4, x5, so on and so forth. Given these conditions, what can we say will be your output? So chance of the value given these input factors, right? So that is your conditional probability. So we can write it as probability of your output category, one of the categories, given all these input factors. And when we talk about this conditional probability, if I basically try and write it as two events, the second event given the first event, we will generally write this as probability of A and B, joint probability basically. I'll say A and B divided by probability of A. So given the probability, right? So what is the joint probability that we have? You can also express this as probability of A, probability of A given the B conditions, and then probability of your overall B. So this is another way to represent your naive Bayes algorithm. And naive Bayes is very, very, very popularly used in identifying whether your email is a spam or a ham case. Okay, very, very commonly applied use case. The advantage is that you will try to measure the probabilities of your outcome based on input variables. So it's a pretty simple technique, hence it's called as a shallow machine learning algorithms. And even if you have large amount of data sets, the naive Bayes seems to be working very well because it's ultimately the probability that we are trying to calculate. This is basically the overview of your naive Bayes algorithm. And when we talk about the naive Bayes, the application also I have mentioned, but yeah, it is not restricted to that. We can also try and use the naive Bayes algorithm to predict the numeric output as well. And anyways, you have non-numeric output scenarios that I just explained. Though we have a disadvantage with naive Bayes, which is called as zero probability problem. We'll talk about that in detail again, right? So we'll try to continue that, more about that discussion. Yes. Hope that answers the question.
Yeah, thank you, Sharath. Yeah. So you mentioned specifically about the ham and spam application. I'm assuming that is because the ham and spam application is because we can, using the textual data, we can create a large quantum of features. Each word becomes a feature. So does it, am I to understand that the Bayesian classifier or naive Bayes works well when the number of features are very high? Is that the thing about it? If it is lesser features, how would it behave? Could you just throw some light on that?
Yes, very correctly mentioned, Nathan. That's the exact point. Naive Bayes algorithm, as we discussed, right, conditional probability based calculations, it definitely works well when you have more features, because each feature's effect in getting the output should be captured in the right manner, and naive Bayes is able to do that very, very appropriately well. You can also apply this with respect to less number of features as well, but it has an advantage when you have large amount of values. And the formula itself is a very simple algorithm, so it really does not have a heavy computational burden on large columns.
All right, thank you. So we also are aware of some of the variants of the naive Bayes. So could you throw some light about those aspects as well? What are the variants?
Absolutely, absolutely. So whenever we talk about these shallow techniques, right, a lot of default interpretation is that it works only for output variables which are non-numeric. But see, when we are trying to apply a concept in order to capture non-numeric outcome, then the same concept can be captured for or used for capturing numeric outcome, right? So it's not that difficult. So naive Bayes algorithms are used as regressors as well, right? And of course, we are talking about classification concept, right? Classifiers. And naive Bayes predominantly comes in 3 variants. Let me show you that. Yeah, this is the case. So this is the mind map, or you can say cheat sheet, which allows us to identify what are the various functionalities that your naive Bayes algorithm has from sklearn. The package itself is called as sklearn.naive Bayes. And it has variants, right? So Gaussian Naive Bayes, Multinomial Naive Bayes, and we also have Bernoulli Naive Bayes. All right, so these are the 3 variants. You can also try and go to the official documentation here. I would say sklearn Naive Bayes. Right, you can directly go to the sklearn.org folder. And you can see these are the various different options that we have with respect to Naive Bayes implementation. If I go to the first one, right? So if you talk about Gaussian Naive Bayes is basically algorithm which is typically used for the target variable which follows continuous output, Gaussian right distribution. When you have multinomial data, that is your output variable contains nominal data, right? In such cases, we go for multinomial Naive Bayes, right? Multinomial distribution. We also have complement Naive Bayes, and we also have the Bernoulli. The 3 important Naive Bayes algorithms are Bernoulli's, Gaussian, and multinomial. Multinomial is what we were talking about with respect to classifying an email into spam, ham, or multinomial, right? So it could be important folder, it could be promotional folder, it could be spam, it could be various other folders that you see in your Gmail, for example, today. So given the various inputs, that is the content of your email, where should I place that email? Should it go into spam folder? Should it go into your inbox? Should it go into promotion? Should it go into social media folder? Should it come into the important folder? Right. So this kind of classification is something that it learns. Right. So these are the different variations that we have, and Bernoulli is typically applied for your binarized output, binary value. Okay, so that is basically how it works. Yeah.
Yeah, thank you, Sharath.